past decade, leftover food or knownly as solid food waste from any restaurants or even household is rapidly increasing. In Malaysia itself, the data is recorded for over 16,000 tons per day of total food waste in Malaysia.
Therefore, we are thinking the solution of this problem by converting solid food waste into biodiesel for a good use, and to see how far the performance of the biodiesel from solid food waste. I'm Nur Shuhadah binti Baharudin. My ID number is TC18060 and my partner project name is...
And I, Muhammad Adib Qushairi bin Abdul Karim, TC18088, will present to you the performance of solid food waste biodiesels on IC engine applications.
So why do we choose this title at the first place is because of the energy. Energy play a crucial part in our life and even in industry itself. So the demand of energy has been rising globally along with global emissions. So one of the best choice here is the biodiesel is because it emerged as a sustainable, biodegradable and also environmental friendly. It's also an alternative to substitute our current fossil-based diesel fuel. But there are some other problem and issue that we need to deal because of the first and second generation feedstock. So third generation biodiesel feedstock is chosen because it have a potential and alternative to overcome the problem of first and second generation feedstock. So the problem that we have over here is we have the highest number of solid food waste that generate in Malaysia, and also we are lacking the numbers of research to find that focus on lipid extraction from solid food waste microalgae in order to produce biodiesel. So that is very important to study the trans-esterification of solid food waste microalgae to produce biodiesel. And the last one is there are no other information that clearly state about the performance of solid food waste biodiesels on IC engine application.
Next is the objective of this project. The first objective is to investigate the trans-esterification reaction of solid food waste microalgae by using sulfuric acid and potassium hydroxide catalyst for biodiesel production. The next one is to evaluate the performance of solid food waste microalgae biodiesel for internal combustion engine applications. So we move to the next slide, which we will talk about scope of study. There are two scopes of study that need to be highlighted here, which is the first one is trans-esterification reaction. From this reaction, we want to study what is the reaction for trans-esterification if we use acid sulfuric and also potassium hydroxide. Those two catalysts will be used separately. From there, we will study three parameters that count from the result. Firstly, the effect of methanol to oil molar ratio, and then the effect of catalyst dosage, and lastly, the effect of reaction time. As you can see beside those parameters is the data that will be taken from this reaction. And finally, this data will be calculate the percentage of biodiesel yield and evaluate the fatty methyl ester or FAME through GCMS. And the next one is the IC engine application. So basically at this part, we want to study the IC engine performance by using two parameters that will be calculated, which is brake thermal efficiency and also brake specific fuel consumption. So the standard that we will use is ASTM D6751 standard for this run. There are 5 of properties that need to be taken, which is the density, acid value, saponification value, kinematic viscosity at 40 Celsius, and lastly the water content volume. So the next one, I will explain to you about literature review that we referred for this project. And the first is about biomass, which is Joseph said in 2018. Biomass is one of the three main renewable energy that have a potential to grow globally, alongside solar and wind energy. This statement is supported by Gramelis in 2016, which he said biofuel are a form of alternative fuel made from biological, mineral, and renewable source, which play a crucial part because it met the future demand by increasing sustainability and minimizing the greenhouse gas emissions. Additionally, Ahmad stated in 2019 that third generation biofuel feedstock, which is algae, is an ideal biomass source for biofuel because we can generate large quantity of lipids and it can grow in variable environment and also grow faster than terrestrial plants. So the next one is two extraction method in this experiment are supported by these two statements, which by Gaetano in 2020 said solvent extraction method for lipid extraction are most popular because they provide the most recovery in lipids. And also this method is commonly used for extraction of lipids until now. And the other method is supported by Hiroyuki, who said in 2019 that microwave assisted extraction is a process of using microwave energy to heat solvent in contact with a sample. And I believe from this statement that this method is acceptable to use in this project. And the next one is about trans-esterification, which Mozani said in 2019. Trans-esterification reaction is the way to generate methyl or ethyl ester of fatty acid and glycerol. This is an important step in production line of biodiesel. And lastly is supported by the statement of Toshihiro in 2019 that homogeneous catalysts such as transition metal complex has been used for chemical reaction. This is so important in this experiment. This is because homogeneous catalyst type is chosen to be used in trans-esterification reaction in this project.
What materials and equipment are used in this project? The materials that will be used in this project are ethanol as a solvent in lipid extraction. After that, methanol will be used in the trans-esterification reaction. Next, catalyst used is acid sulfuric and potassium hydroxide. Then, the mixture of methanol and catalyst will be heated in silicone oil bath. For equipment, which is drying, will be used oven. After that, microwave, centrifuge, blender, sonicator will be used in the lipid extraction. And lastly, equipment that will be used in trans-esterification reaction is the rotary evaporator. For methodology, firstly, 10 kg of solid food waste will be collected from restaurants in Gambang. Then, the solid food waste microalgae will be cultivated for 14 days under sunlight and separated moisture content by the oven for 24 hours. After that, grind the sample into powder. Go through to the lipid extraction, which is the dry powder sample are added 30 ml of ethanol and treated by ultrasonication. Then, heat the mixture in the microwave. After that, centrifuge the mixture prior to filtering the extracted lipid. Then, the concentration of free fatty acids in the lipid will be determined using a GCMS. Next is trans-esterification reaction, which will be performed by using methanol. Catalyst used is sulfuric acid and potassium hydroxide. Trans-esterification reaction is performed in a 3-neck round bottom glass flask, which is 250 ml fitted with a reflux condenser. a thermometer, and a digital hot plate with a magnetic stirrer at 65 degrees Celsius. Then, add the desired quantity of catalyst, that is sulfuric acid and potassium hydroxide, and continue heating until optimum time. The mixture is heated and mixed with vigorous stirring in a silicone oil bath to maintain the temperature in the reaction. Then, biodiesel will next be measured and analyzed by GCMS to identify the composition of fatty acid methyl ester. Furthermore, ASTM D6751 standard compared biodiesel attributes with the current biodiesel standard. Lastly, IC engine testing will be determined by brake thermal efficiency and brake-specific fuel consumption. This is the formula to calculate the yield percentage of biodiesel, brake thermal efficiency, and brake-specific fuel consumption. This is our Senior Design Project 1 work schedule. Based on the schedule, the complete week is 14 weeks, which for week 1 starts with group member recruiting, supervisor permission, and first project discussion. Then, from week 2 to week 6, we started chapter 1 to chapter 3. After that, we made overall modifications from week 7 to 10. Then, after the supervisor approved our preparation of the presentation proposal, the presentation proposal will begin in week 13. Then, finalize chapter 1 to 3, submit logbook and proposal, and submit peer review form to coordinator in week 13 to 14. For cost analysis, our total cost is around 173 ringgit. That's all from us. Thank you.